So now what do we have here? So I've got an aldehyde. So there's the aldehyde. So that's the aldehyde that is not going to last. But let's draw the rest of what's left in the pot here. So we've got we just protonated that, right? So there you have that. Now what? Well, you guys remember from general chemistry, we have a dipole moment in that direction, right? Up through the carbonyl, putting a partial, I could do this in a different color, partial negative charge right there, right? Partial positive charge right here. So what does that mean? Well, it means you can take these electrons, right? And we're going to protonate the carbonyl. What ends up happening, how much space did I give myself? Oh, good, lots. So what am I going to do? I'm going to protonate my carbonyl. And what that does is it sort of makes that carbon hot for nucleophilic attack. And what else do we have in the pot? Well, we had some water, and we still do, causing trouble or doing its job if you want carboxylic acid, right? So this aldehyde is history now. So we've attacked the aldehyde. Let me just, geometry be damned, we're just going to draw what we have here as it is. There. Water's going to come back in. It's going to deprotonate here. Return the electrons to the oxygen. And you're going to get this species, which can now attack all over again, right? So we're going to attack this thing. What is this? This is our Jones reagent all over again. So we can pick whichever one you want. I'll pick this bottom one here. We're going to attack the chromium. Again, we're going to delocalize the electrons. Let's see what we get. So down here, I've got R, C. Let me draw this all out. Try to draw this out as suggestively as possible so that it's clear what's going on. There. So that's going to be our intermediate. We've got water in the pot. I'm going to take that hydrogen off, return the electrons to the oxygen, and draw this out over here. There's a hydrogen on that. Okay, so just like in the other reaction, sorry, this takes a little bit to draw out. So what we're going to do is we are going to do another E2 reaction. So finally, right? So we're going to take these electrons, we're going to take that hydrogen off of the carbon, right? That carbon was the carbon that had the hydroxyl group on it in our primary alcohol. And these electrons are going to come up here and make a double bond between the carbon and the oxygen, and we are going to kick this off right? Kick off the chromium. And what do you have? What do you care about? Not the chromium. We have, let me flip this around. There's the carbonyl. And there's the hydroxyl group. So this is your carboxylic acid. And of course, you've got the rest of your chromium nasties in the pot. But this is an E2 reaction as well, right? And this is your carboxylic acid. So we got a bunch of action here going on with this water, right? Without it, you end up with just the aldehyde, right? With the PCC and under anhydrous conditions, right? We can stop at the aldehyde theoretically. Down here, though, it's involved in a bunch of steps in this proposed mechanistic pathway. So we can take a primary alcohol up to the aldehyde. We can take it a little further and oxidize it up to the carboxylic acid with Jones reagent. What if I had a secondary alcohol? I am not going to do this mechanism again, but I can take, say for example, a secondary alcohol. So you can take R, CHR, and then a little hydroxyl group up there. And I can put this in with Jones reagent, some water, and I get a ketone. Sorry if you can hear that, that's my cat, and she has allergies. I get a ketone. You can try out the mechanism if you like. It's the same old thing with the secondary alcohol. We've got the hydrogen that we're going to use in the process. We are going to oxidize this carbon, right? So the process is going to be the same. The issue here is with the tertiary alcohol. So with a primary alcohol, right, I've got, say, CH3, CH2, OH. With a secondary alcohol, I've got two R groups bonded to that carbon that bears the hydroxyl group. But notice how that carbon still has a hydrogen. So you can highlight this if you like. We're talking about, here's the carbon that's going to get oxidized, right? And then here's the hydrogen, one of them anyways, that we need in that mechanism. But what doesn't the tertiary alcohol have? It doesn't have that hydrogen. And this is part of our proposed mechanistic pathway. The other thing we know is that tertiary alcohols do not undergo oxidation. So here I can say, let's take this up to the aldehyde, and that's fine. And I can oxidize again. To the carboxylic acid. I can take a secondary alcohol and I can oxidize it to get a ketone. But if I dare to try to oxidize this thing, nothing happens. So we propose those mechanistic pathways using that hydrogen, and we believe that's the reason that the tertiary alcohols are not going to undergo oxidation. So let's talk a little bit